Hello and welcome back to another session of Effective JaRu, the series where we will read effective Java and see if we can apply the items presented here to idiomatic Rust. It's generics time, and it's generally not too difficult to parameterize your collection declarations and make use of the generic types and methods provided by the JDK. Writing your own generic types is a bit more difficult, but it's worth the effort to learn how. Yeah. I'd agree, it's a bit more difficult, but once you have dealt with Rust generics, then this doesn't seem too difficult after all. It's just interesting how they behave, because it's really, it's a bit tacked on, and there are special cases. And this example here, you know, we build a stack. The stack was presented multiple times in the course of the book, so it's kind of nice to have it as a recurring guest here. So in the first technique, this is parameterized so that you have a stack of items instead of a stack of objects. So the previous one was just a stack, which is the raw type. And I wonder if you automatically have a raw type as well. But I think so, huh? Probably a list in Java is just implemented in Java, so same rules apply. Without needing to use any weird intrinsics that make it special. So I guess that's the raw type here, and that's the type parameter. And yeah, this is one that I would probably kind of like. We have a slice, I call it a slice, which is kind of what it is. It's an array of elements of type E, and everything else is the same. So if you look at it, everything takes E now. We pop E's, we push E's, and nothing else really is so important. We can do it like this, apparently. You have to redundantly specify everything as usual. I mean, I can only show you, let's show it. I show you how this would be done in Rust. Of course, I'm using a pre-made vector because that's more like a cheap vector. And in Rust, of course, you wouldn't do that. I'm sure you have vectors in Java as well. But I'd like to at least show how the interaction is with generics in Java compared to in Rust. I think I've shown something like it, but I might show that again. Why not? So let's go there. I'm terribly unprepared, but that shouldn't be a problem. Do we make a binary? No, we make a library with a few tests, or no, it wants to work with args, so we make a binary here. Item 26. I still have to make projects that explain why these don't really apply, but yeah, so that there are no gaps. Anyway, item 26. No. Item 26 main. So in order to do that, we use a vector, right? This is automatically pre-imported. That's very nice. So we don't have to do anything really. So what do we have? Let's use the same variable names. Let my stack be a vec new. If I wanted to just stupidly do that, right? I need the argument. So std env. Use std-env at least. So now I want to iterate the args for arg in env args. That will provide an iterator anyway. Tells me that it's unused, or that the type could not be inferred because I didn't specify any type yet, right? So now I can push the arg here onto the stack. Now it receives a type. And then I could pop it, that kind of behavior. Okay, pops from the end usually. Yeah. While I think we would do well with the while let here. While let some item in stack pop. So that's exactly what this is made for. We can print this item here. So that is really a very, very difficult, complex way to do that, but I just want to show how it looks like. So as you can see, on the right side, we actually have type inference everywhere. We don't see types really. It looks more like Ruby than it looks like anything else. Except for it's fast and safe, right? So let's run it. Item 26 cargo run. So that should do nothing except for printing our own executable name. And now arguments are 1, 2, 3, 4, 5. And there we go. In inverse order. So this is what we just did. But in, you know, that's one way of doing it. The normal way would probably be that, yeah, I don't know. I don't think you would do any of this really. So let's not do it. I can just tell you that obviously this is something you would do in one line. Let's do it. If I say you can do it, then I should show, right? So let's see how far type inference gets us. So env args collect. So collect apparently doesn't know what it should do, which is fine. So we now tell it that it should collect into a vector of strings. And now we kind of do the same thing, right? This prints all the items out, but in order. So that's how that looks like. Oh yeah, we could even make it a bit prettier. And there you go. So that's a pretty printed vector of strings in Rust that we generated from an iterator, right? That's an iterator. And we collect everything into something else. You could also collect into a hash map, for instance. Well, I don't know about hash maps, but in all kinds of things. We could also collect into a string, maybe. It's really interesting. I would have to see how collect is implemented. Because it's way more flexible than that. You can collect characters into a string, for instance. That's how that works. I think, yeah, let's see how it's implemented. I'm wondering. What does it need for things to be collectible? Show me. So that just returns the iterator. Ah, I see. So the return B must implement from iterator, and from iterator provides an interface that takes an iterator and then does the right thing. So you can be collectible too. That's pretty cool. From iterator, see, makes sense, makes total sense. So that's how that works. But yeah, that's how you would do it in Rust, and it's as easy as that. 8 minutes in, might as well have a look at item 27. Favor, so here's favorite generic types and a few. Oh yeah, we didn't really discuss the option 2 yet, just because I didn't find it too interesting, and maybe we should also look at this. So the elements array will contain only E instances from push E. This is sufficient to ensure type safety, but the runtime type of the array won't be E, it will always be object. Yeah, so your casting here, you say that this is compatible. That's basically what you say. And this cast here is unsafe. It can't be verified at compile time. This is why you get this warning. If you build it, oh look, warning, serializable class empty stack exception is no definition of serial version UUID. Okay. Is it serializable because it's derived from runtime exception? Apparently. Okay, so I don't know. That's probably something new that happened in later Java versions. It's interesting, you know, that's inheritance. But I don't want to implement serializable. Well, you have to. With traits, everything is horizontally laid out, right? You don't inherit stuff. There can be requirements that can be specified, but usually these are made so that you don't combine orthogonal concepts. Yes, you can have an exception that is not serializable or doesn't have a serial UUID, whatever. See, that's kind of unexpected behavior there. And there's something you usually want to prevent. Yeah, so this cast here is the thing that you have to suppress, right? If you do it, then you get an information that this is an unsafe thing to do, an unchecked cast. In Rust that doesn't exist anyway. I mean, the type system is so far quite bulletproof. I say quite because I know you can have cyclic references of RCs, or reference counted pointers, which can then lead to leaks, which can lead to interesting effects. You can manufacture that if you like, but there, I think with Rust 1.2 or 1.3 this will be nullified and made impossible. Anyway, that's version 1. Let's have a look at version 2. Version 2 still keeps working with an object, saying, well, we can't have a parameterized covariant array anyway. That's kind of the idea here, right? We can't have that. You know, I would say, well, let's have an E of this. But this apparently doesn't work either for the reason that generic array creation, see, that's forbidden because these are covariant and blah blah, and that's how. And see, this is the weirdness. God damn it! What's the problem? You know, Go does that with its slices and the special compiler provided function called make. And make can just create slices of anything, but that's kind of the only generic thing that Go has. And so far, nobody complained. Still very flexible, I'm saying. And yeah. What else? So that's the weirdness, right? You have to work around this. Ideally, you never have to do this yourself. And I also wonder why you would want to use arrays or these slices here for anything. I would want to use a pre-made, you know, if I want a sizable thing, then I want to use a vector, and it should be as fast as it can be, and I don't want to deal with it. So does Java have a vector? Java vector. Vector, yes. There we go. It's an abstract list. Abstract collection vector. Growable array of objects, like an array. It contains components that can be accessed using an integer index. However, the size of the vector can grow and shrink. So yeah, that's the difference. Each vector tries to optimize storage management by maintaining capacity and capacity increment. La la la. Okay, so how does it look like? We have add. Oh, add is you know, do we have add and push or what? No, we don't have push, we have add. That's interesting because add usually implies a set operation. That's how I know it. And this is not a set. Add at index. Yeah. I'm bitching about many things these days. And this unholy hash code. Returns the hash code value of this vector. How is that implemented, by the way? How does it generate a good hash? It gets the hash of all items and then exclusive ORs then, or what? Where's the code? Can you look at the code here? No, you can't. Because it's Oracle, our source code is a private matter. They could at least show that. I don't think that's hidden, is it? Anyway, so the second technique is stick to objects and then do the cast when pushing things on. So here again, the same problem. Sorry, when popping things, right? And pushing things on, you basically bring everything down to the object level, which is an implicit bound if you think about it. So E must be object, right? This is E extends objects. This is kind of the bound you have here. Let's see what happens if we write it out. Yeah, just a warning. So see, that's kind of the same thing. Doesn't change a thing here. But it's implied, I think. And when we are popping, we have the same problem. We have to cast something into E that we can't verify is actually an E. We know it, but the compiler doesn't. And there's no way to fix this, primarily because we can't get a new E array, right? And that is that. Weird enough. I think 15 minutes is enough for item 26. Thanks for watching and have a great day.